Welcome to CW 5.2. Today we're going to review everything you learned about logs last year. So the first thing you're going to do is put a box, and I got to give this to you. This is a standard log, log AB is equal to x. That's going to convert to a to the x is equal to b. So a couple of things you're going to break down. Right there, that's considered your base, and notice how that's also there, base. This x is your exponent, and so is that one. And then the b, I call that the result. So once you have these mechanics down, these problems will get a lot easier for you. And we'll draw a line between it. This is called log form. This is called exponential form. So you have to be comfortable going between either form. So for this one, what I tell people is start at the base and then think like a circle, like that. So 5 to the second power equals x. That's your exponential form. The next one is going to be b to the third is equal to 64. And finally, 3 to the y, that's equal to 7. And that's it for that. Now we're going to go backwards. So now you're going to first write log. The base is 12. The result is x, and that should equal 2. We keep going. Log. The base is b. The result is 8. That should equal 3. And the final one, a lot of people will write this log base e of 9 equals y. And this is perfectly fine, but most books are going to write natural log of y. So recall from algebra that log base e of x is ln x, or natural log x. That's really important. So you're going to want to write that down. Okay, now we evaluate. Now some people have a really hard time with evaluating, and normally it's because they don't really know what they're doing. So you really want to understand that log base a of b, it's asking you a question. It's saying a to what power equals b. So for this one, it's like asking you 2 to what power would make 16. And most of you can just think about it. That's 4. Now, if you didn't like that, this is what you should do. You make it equal to x and just convert it. Just look at that. We can see x would be 4. So you do the same thing here. 7 to the x equals 1 over 49. So you should get negative 2. And then this next one, 25 to the x should equal 5. So that would be 1/2. If you're wondering why, that's because 1/2 is the same thing as square root of 25. And this last one, you could say, well, 2 to what power is the 5th root of 2? So that would mean 2 to the x is equal to 2 to the 1/5. So x must be 1/5. Do a couple more. Log base 7 of 7. 7 to what power makes 7? 1. This one, 5 to what power makes 1? Gotta be 0. This one we can see 4 to what power of 4 to what power makes 4 to the 5th? Definitely 5. And this is the hard one. There's a property I like to teach in Algebra 2b. So you could work it out a similar way that we did before. You could put equals x here and convert this to a log. So you'd write log, the base is 6, the result is x, and that should equal log base 6 of 9. So I can see that x should be 9. But in Algebra 2b, I teach what's called the sandwich property. It's a really cool way to remember this. And this is the idea that if you have a base, it's being raised to a log with the same base here. So notice how these match. And you have some x. What happens is these cancel out, and you're left with the exponent. So you could do the same thing here. Just cross that out and bring that 9 down. Either way is perfectly fine, though. Okay, let's go on. So now we're going to quickly review graphing. So recall 2 to the x. We did that earlier. Your points are 0, 1, and 1 comma base. So I'll sketch that right there. And I have my horizontal asymptote. So something like that. And then log base 2x. The 2 points I want you to remember for this are going to be 1 comma 0 and base comma 1. So I'll do this in blue. So 1 comma 0 is right here, and then base comma 1 is 2, 1. And then this is actually going to have a vertical asymptote right at 0. And the graph is pretty interesting. It's going to look like this. Now you might notice something interesting here. Notice how they reflect over a particular line. They reflect over this diagonal, which is y equals x. And hopefully you remember that that would mean they're inverses. So logs and exponentials are inverses of each other, and that's why we see that happening. So over here, we'll write a quick note. There's HA here, which means logs must have a vertical asymptote. So let's try to graph a log here. Draw the VA, state domain range. So for now, let's just write a parent graph is log base 4x, which means my parent points are going to be 1, 0, and 4, 1. So right there, there's our log graph. And I can see a couple things are happening. Y times 2, reflect over x-axis, and finally left 3. So if I do those, if I do y times 2, this 1, 0 will still be here. And then this 4, 1 is going to be 4, 2. I'm going to connect it here. And then let's see, got to reflect that over the x-axis. Let me get rid of that actually. So reflect. Okay, now that I've reflected it, let's grab it and move it. So this is going to move left 3. 1, 2, 3. And our vertical asymptote, that's right here. And there's our graph. And I'll label those to be a little more clear. Negative 2 comma 0. And this is 1, negative 2. Domain range. So domain I can see negative 3 to infinity. And the range should be all real numbers, since the graph goes up and down forever. Now the final step is just to find the domain. So the easiest way to do this, if you have like y equals log and some kind of box right there. If you're going to put a number into a log, it must be strictly greater than 0. And that's because you can't log a 0 or you can't log a negative number. Like if I wrote this log base 2 of 0, this can't be done because you can't say 2 to some power equals 0. Or if this were like -2, that also can't be done because you can't raise a 2 to a power and get -2. So because of that, this is your key to figuring out the domain of a log. So we're going to grab this thing. 3 minus x must be greater than 0. So x should be less than 3. So there's our domain. Everything less than 3. Okay, now this one's kind of weird, because if I grab this thing, x minus 3 squared should be greater than 0. This is quadratic, so a little bit different. We can't just square root it to figure it out. We're going to draw a graph. So I can see my zeros are 3, and it should bounce. So something like this. And it's saying where is it greater than 0? So that's pretty much everywhere except for that 3. So we're going to write -infinity to 3, union 3 to infinity. And that's our whole lesson.